what I want to talk about here is Sharding MongoDB. We started out as a company that has been predominantly a MySQL house, where our first game was in MySQL, and we had our own attempt at sharding, and we've been able to do it with MySQL, but we wanted to find a better solution. So I'd like to introduce Rick to talk a little bit about himself.
Go ahead. My name is Rick. I've been with Cie Games for about 12 years, so long time. Cie Games used to be called Choice Internet, and then we have our own division. 12 of us went to Cie Games, and we've grown to about a little over 50 people now. And I've been doing everything basically related to technology, starting from coding HTML, now all the way to Mongo. So yeah, and we're in casual games now.
So again, my name is Eugene, and I've been with Cie Games for 2 years now, and I've come from different industries, all the way from making X-ray machines, R&D for security X-ray machines for airports, to working on network security and creating applications that scan your network for vulnerabilities and presenting a list of fixes that you need to do to stay within compliance, all the way to publishing of business-to-business publishing of documents in the mortgage industry. So very different industries. I left the gaming industry, of course, and want to stick with it. And I've been a technical director in charge of operations at Cie Games, mainly working on new technologies like working with MongoDB and Android development, working with different outsourcing teams, third-party teams that we have relationships with, and so on. So what is sharding? Basically, it is horizontal partitioning, and the way that you split the data based on rows. So you have, let's say, a regular database of user, and you have 4 users. And when you shard that database, you have 2 users in one shard, 2 users in another shard. It's row-based, it's not column-based. And it's used predominantly to solve a few problems. So why shard in a game? Well, the first example is when your write throughput exceeds I/O throughput. And how does this happen? So this is a screen grab from one of our games called Cartown. It's one of our most popular games. It has had over 60 million users since we started the game. It's had its 3rd year anniversary about a few days ago, and it's still hugely popular. And one of the things that happens in the game is you're placing items which have, after some maturity period, they give off coins that you can later use to purchase different items. And these coins, a user will come in and they will click on each coin to collect it. So obviously, when you're dealing with money or monetary transactions, you want to log every single transaction atomically and make sure you're writing them to the database, because the next thing that this user is probably going to do is use those coins. And
quick question, if you don't mind.
Sure.
In the meantime, how do you update these like numbers and clicks? So you do like AJAX calls, or you keep like a WebSocket open, or
these are REST calls.
So what are these REST calls?
Yes.
Yeah.
So why else would you want to shard in games? Well, to speed up your database throughput, you want to hold as much of your active audience in memory. And the best way to do that is distribute the load onto multiple systems, which will then cache your database database requests and speed up your throughput. Oh, sorry. So this is drawn by one of our artists, just so you guys know. He's trying to fit into the little car. Just pun intended. Why else would you want to shard games? Well, when we start out building out the game, we don't really know how big our audience is going to be. Obviously, we have projections. You know, we have a great analytics team, business intelligence team, which goes through, and you know, we've already had past great performing games, so we kind of already know a little bit about our audience and who we're targeting. But you know, you never know from game to game what the audience is going to look like. Obviously, you want to save money initially until your audience starts growing. So you have a choice, either to grow vertically or horizontally. With horizontal growth, we can do this in the cloud, and it's really easy and really fast with commodity hardware. And you know, something like where you're sharding across multiple database servers or application have a large application layer is really easy. So why did we choose Mongo for sharding? Well, like I said, we have already tried sharding with MySQL. It's very painful. You either have to deal with proprietary drivers that are going to do the sharding for you, or you have to write your own sharding layer within your application, and obviously have separate pain points due to that. So with Mongo, you can distribute objects within collections automatically. Essentially, it gives you sharding for free. And you can choose how that data is partitioned. You can also go from and create one single instance and have just one database, and then shard later on with zero downtime. So it's perfect for cloud-based installations. It's fully consistent, so something that we definitely want in a game, and it, yeah, like I said, works well in the cloud and has automatic failover. And for us, that's very important because no user ever thinks that a game should be down. So we try to get 99.999% uptime as much as we can. And the other thing with Mongo for us was that it has, because there are other technologies that are similar to Mongo, with Mongo, it has a really good tool set for Java development. And we're a Java house, and we've been developing in Java already. So our core logic has been in Java when we developed Cartown. So for games that, you know, they're gonna come out in the future, and for games that have already been released, like Cartown Streets on mobile, they have reused a lot of that logic. So it just made a lot of sense for us. So shard design. So you want to how you design your sharding. You want to share the load amongst all the shards equally. That will give you the best performance. If for some reason one shard is heavier utilized than another, it would make it very difficult for you to manage. So you want to introduce some kind of high randomness, as well as you want to have the smallest working set possible. So possibly roll with time. For us, you know, we know how long our users generally play the game if they're new users. I myself as a gamer is kind of a typical new user. I love to play games for 24 hours, 48 hours. I'll play them all day, all night. log in when I'm at 2 in the morning when I can't sleep and play the game. But then at some point I just burn out and I don't want to play the game anymore. So that's a lot of users, I feel like. And obviously you're still going to have some core audience that builds up over time. But you'll, as a viral game, you get a large influx of users right away. So one of the things that we wanted to do is recreate the shard key from the object ID. And be careful how you shard, because there's no way back. What I mean by that is, once you've sharded your data, if you want to shard by something else, you will have downtime. And on a critical game, you don't want that to happen, especially if you figured out that, oh my god, I have so many users now and I need to keep up with it. And if you've already sharded it the wrong way, then you're SOL. So why we shard kind of based on an object ID is that 99.999% of our queries are related or can have the object ID involved. For example, when a user logs in the first time, we generate the object ID for that user. And then after that, it is stored with the client. So, for example, on our Cartown Streets game, we'll generate the object ID, and then we will save it on that client for later relog in, and then we don't have to do any kind of range-based queries to try to find the client or find their specific user ID. And most users, what they're doing afterwards, after they log in, they're interacting with their own assets, with their own, let's say cars, parts, items, buying things for themselves. So anything that you're storing from then on is essentially part of their user's document set, and doesn't require to do any kind of range-based queries as well. And if we ever do need range-based queries, we try to offload that. We'll either not do it on a sharded environment and on a small subset, or we'll use some other reporting tool, reporting database that is better suited for the job.
What would be an example of like a range-based query?
Range-based query would be like find users who have a level of 5. So you're finding all users that have a level 5, or find the users who logged in the last 5 days.
And you're saying that's not your typical use case, which is why
That would not be a typical use case, yes.
So like you keep all those little objects, like they're like whatever tokens and coins.
Yeah, exactly.
Within the same.
Within the
document.
same, yes.
Within the same like document as the user. Or?
Correct. Yes. So the user has some set of money. It has, or tokens, or coins, or gold, or whatever it is. It has X number of cars. The cars have X number of parts per car, and so it's all nested within.
So it's nested like just
one big document. Yes. And usually the user will want to load it in initially when they're getting into the game. And then after that, we can, with Mongo, luckily, we can do incremental updates to just specific fields if we wanted to. So we don't necessarily need to push back and forth an entire object on the network. So what is a shard behavior? Well, when you attempt to insert data into pre-split chunks, sorry. So shard behavior, this is what we want to do to increase performance. So we attempt to insert data into pre-split chunks. And this increases cluster throughput by reducing overhead. And what I mean by that is when you're inserting things into chunks, the database, Mongo database, will try to fill that chunk and on the same database shard. And and then once it finishes filling that chunk, it'll go on to the next chunk and so on, and it'll keep doing that, and until it finds out that it's off balanced. And then once it finds that it's off balance, it's going to start moving those chunks to the other shards. And the movement is obviously expensive, and you want to try to avoid that as much as possible. So as an example, if we have users like me who play for 3 days, and after that, my lifetime is 3 days. So we'll use that as an example. So most players expect to play an average of 3 days, let's say. So we want to come up with an algorithm that will balance out the users using the shard key prior to actually having the system do it for us. And then if there's anything that's still unbalanced, we want to rebalance during off-peak hours so that it doesn't affect the game performance. So what is a pre-split? Pre-split, it creates chunks and moves them to different shards ahead of time. And it creates basically 0-byte chunks. It's kind of a way to tell the database where the users are going to go before they're actually created. And later on, these chunks, if the data still doesn't fit into those chunks, they'll grow to 5 or 6 chunks for, let's say, depending on how many new users there are. Obviously, there might be, let's say, some kind of promotion where we're funneling users from another game during a specific time frame. Maybe at that point we'll get a large influx of users, or let's say we got published in some article or showcased at E3 at some huge event, and then all of a sudden there's like 1 billion installs. So those things, we can't guarantee how many chunks that will be created, but we know that if we do this kind of system, it will somewhat evenly distribute the data, and then avoid the balancer rebalancing them. So how do you create a 3-day shard key? Well, a 3-day shard key would be 2 to the power of 18 will equal to approximately 3 days. And we know that an object ID consists of a timestamp when the ID is created. And we want to generate some kind of consistently random value, which we know is going to be fairly distributed evenly. So we can take MD5 of the string version of the object ID, and then take the first 18 bits of that MD5, and then append it to the timestamp of the object ID. So that's how, one way. Obviously ours might not be 3 days, but that's one good way of how we figured out we can create a shard key. So Mongo has kind of solved this for us a little bit with 2.4. They have hash-based sharding, and there's no longer a need for pre-splitting with hash-based sharding. It's easier to set up. You don't need to write the code that we will show you at the demo for sharding. Obviously, it's a pretty good distribution of sharding. What it does is almost what we do, which is it creates a 64-bit MD5 and uses that as the shard key. So it'll take whatever index that you have as a hash index, and it will, be it a URL or whatever, Facebook user ID or whatever you're using, even object ID, you could use that as well, and it will create a 64-bit hash. So then it'll distribute it evenly. Doesn't support compound indexes, so something you have to watch out for. And you cannot use floating point, because what happens with floating point, it rounds them off to nearest integer, and you're not going to get even distribution. And just like with our sharding mechanism, it has the same inherent issue, which is you don't want to do range-based queries because it's just going to go to all the shards at once. One of the limitations that we found with this system and why we haven't used it is that the working set is distributed against all the shards. This does not allow us to have good... Rick can probably talk about this a little bit more.
Okay. The problem for our game is, like what Eugene said, a lot of people will try to play the game, and then you probably have about, like a good game will probably have about 10% people that will stick around and keep playing the game. So you can, basically, let's just, for argument's sake, we have 90 to 10% ratio of new people that currently playing your game. So with Mongo, it works really well if all your data, which is basically the data plus the index, fit in the memory. Once it gets bigger, then it works kind of well if you can fit the entire index in the memory, and then you have your entire working set, which is basically the data that you need to pull from the database within the memory. What that allows us, not doing the hash sharding, is the way we design the shard key is we bulk the 90% within the same chunks, so that when we need, I guess if you have like if you have 90% of the users as new, then 90% of the data is bulked into one area, the chunk, so that when you put it in memory, then you're only putting, depending on how long the game has been running, you're only putting a fraction of your data to the memory. Therefore, you don't have to keep buying new memory or keep adding shards to your hardware cluster. So that would save us some cost and more predictability in terms of, like, if you have an influx of users, then your system can handle it, as opposed to you have to react a lot faster. And my God, we're going to have double of users, then we need to double our hardware. So
there you go. Yeah. So sharded development environment, I can either go through the slides, or Rick can just go and show you as a kind of a actual demo of it. Raise your hand. Which one would you prefer? Demo? All right, demo.
So how many of you guys have sharded before? Like you use sharding environment? So okay. So I'm gonna kind of explain sharding real quickly. The difference between a regular Mongo environment and a sharding environment is if you don't use sharding, then the best practice is basically having a replica set of Mongo. So you run ideally about 3 Mongo. One of them is going to be a master. So you have 2 slaves, 1 master, and that's how you kind of like. Thank you. All right, so. Okay, so.
It's all locally.
It's all local, yeah. So basically, when you want to run a sharded environment, what you do is you have what you call a shard, which is a regular MongoD, and then the MongoD can have a replica set. So you have master and slaves, and then in this example, definitely not recommended by 10gen for production, but I'm going to do a minimum setup for a sharding environment. So I'm going to have 2 MongoDs in that cluster without any replica sets, so just 2 MongoD, which will hold different data. And then I'm going to have Mongo config, which basically will hold the information of what you call it, which shard belong to that a sharding environment. And then once you have the config and you have the MongoDs, then you run a Mongo S, which is a thin client that you connect using and telling it where the config server is, and then the MongoS will connect to the config server and be able to connect to the MongoDs within it. So the production environment that was recommended is going to be, you should have 3 config servers, and they read from each other. Same thing, have master slave kind of thing, so for failover. And then each of the shard, you should have a replica set with master and slave. So if one of the master goes out, then there won't be any downtime, and the automatic failover will work. And then for the MongoS, you can have unlimited, and it's better if you have a MongoS residing locally to your application. So for example, if you have a web server like our REST API, then you have a Tomcat running with MongoS together, and then the Tomcat will connect to the MongoS on localhost. So on this demo, I'm going to run, like I said, 1 config server, 2 MongoDs, and 1 MongoS. I actually prepared it, so I'm just going to cat it. So since I'm only using 1 computer, I'm running them on different ports. So I have the first one is a MongoD with that database path, and it's running on port 27020. And then the second one is running on a port 21, and then I have a config server running on port 19. And then it takes a while to start it up, so I'm going to go sleep for a little bit, and then I'm going to run the MongoS running on a port number also 19. That's the wrong one. Let me modify that. Oh, never mind, sorry. This is correct. So I'm running a MongoS connecting to the config that is on localhost on that port, which is the config server 27019. So I'm going to run it. So the first 2 Mongos are just regular Mongos. And then after that, I'm running the config, and then config will read and make sure that all the Mongos are up. And now the MongoS is running. So I can just connect to my Mongo localhost, and I can show the databases, and I have that sample DB. So in the sample DB, I have a sample data in the user collection. So if I do a find, then I have 3 data here. So as you can see, we used object ID as the primary key.
Well, actually, it's a bit hard to see it,
Oh. Move forward. I mean, I don't know how to control and make it bigger. Maybe I can change the font, but
There's a little.
let's see here. Edit.
Just the plus key?
The plus key.
Yeah,
Command plus.
There it is. There.
Oh, there you go. Thank you.
so much better.
Is that better? All right.
Okay. So he ran Mongo over here, and he connected to. He showed the databases and used sample DB, show collections, one find on the user table collection, and return these 3 users.
Right. So we have these 3 users, and these are the auto-generated object ID every time you insert into the Mongo. And how many of you are familiar with what comprises the object ID? Okay, so the object ID is essentially is somewhat similar to UUID in regular programming, but it has less bits, so it's not as long. It doesn't take up as much RAM. And the way they do it is it's a combination of the time in seconds in UTC, which is the important thing that I want to emphasize on this sharding environment that we have. So it has time, it has the process ID of the Mongo process. In this case, if I'm running a Mongo client, then it will be the process ID of the Mongo client. If I'm creating it from my web server, then it will be the process ID of my web server. In this case, it's going to be Tomcat. And then it has also the machine ID. So if you have MongoDB running on different servers, then it will be a different machine ID. And then if you still have duplicates, then internally it has a sequence. So if you create at the same time from the same machine using the same process, you run it 10 times over, then there's a sequence that will keep incrementing, making sure that this is unique. Obviously, if you, I think the sequence is only 3 bits. So if you, no, sorry, not 3 bits, but I think it's 3 bits. But there's a limit on the sequence. So technically, you can still break it, but then it will break it, or you will create a duplicate at a really high rate that's not going to be your problem. Your problem is you're creating too much data anyway. So let's just assume that these are unique, right? And then because the time is actually, I believe that's the last bit. So I basically created these two, one after another. And as you can see, they're almost similar, but there's like a little bit of difference. But they're different.
From here.
Right.
Right.
So we have an algorithm that anytime we have an object ID, we can always create a consistent shard key. So this will always generate that. So every time we do a query on the object ID, then we can always regenerate the shard key, so we know exactly which shard that data belongs to. Now, if you look at, because I'm connecting to the Mongo OS, then I get the entire data, but in actuality, some of these documents are in shard number 1, and some of them are in shard number 2. The way you tell is by typing sh.status, and then if you want to get a full status, you pass true. Now, it basically tells you that these are the 2 MongoDs, or Mongo replica sets that it connects to. So I have shard 0000, shard 0001, and these are running on the MongoDs locally on these ports. And I have all these databases, and they're not partitioned, meaning that they're not sharded. My sample DB is sharded, so it's partition equal to true. And it'll say that primary is shard number 000. What primary means is if you create a new collection, and then you just mark it as sharded, then the first chunk of the shard is going to go to this shard. And then if there's a new chunk, then the rebalance is going to take over, and eventually it's going to start balancing between the X number of shards that you have. So in this sample, I have 1 chunk on the first shard 0, and I have also 1 chunk in shard number 1. And I basically say that for this sample db.user, this is where the breakdown on how they separate the data. So in Mongo, you use a range. So the range starts from minimum value all the way to maximum value. And then let's say if you have a data, let's just assume that it starts from 0, right? So 0 is within minimum and maximum key. And let's assume that one document is the chunk size, which is 64 megs. So once you have a second data, which is, let's assume that that data is 1. So now you have 0 and you have 1. And that chunk becomes 128 megs with those 2 data. So Mongo will detect that it goes beyond the chunk size of 64, which is the default. Then it'll attempt to cut it in half. And once it cut it in half, then it knows that, OK, 0 should go to chunk number 1, and 1 should go to chunk number 2. So when that happens, then Mongo will automatically, if you run the rebalancing, Mongo will automatically say that from minimum key to 0, you go to number 1. From 0 to maximum key, you go to number 2. And then let's say now you have those 2, and then you add number 2, right? Now you have user number 2, same thing, 64 megs. So now number 2 will stay within that range of 0 to maximum key. So now 0 to maximum key has 1 and 2. And then again, it will split it again, and it'll say, OK, that's too big, 128 megs. Now, 2 will have to go to a new chunk, and then they'll just keep moving that. It'll just basically split like as evenly as possible, put it into a different chunk locally, and then it'll look at locally on the shard. Okay, this shard has 20 chunks. That shard has 18 chunks. Then I'm gonna move that one chunk to the other server, so now we have 19 and 19. In actuality, there's a magic number. I'm not sure if it's adjustable, but as of 2.3, I believe it will be 9. So if one chunk, if the maximum number of, if one shard has a total of chunk that is 9 more than any other chunks, then it'll start moving any other shards, then it'll start moving the chunks and rebalance to the rest of the shards. So in this example, this is the first range is the minimum key of 1, and then to the shard key of value of 13708 to this value. That would be on shard 0000. And then the second one is from the same number, 137080145, to maximum key will go to shard number 1. So going back to that, you gotta remember that number, right? So if you look at the one on the top, that one will fall 137 below, right? So it'll fall on this chunk.
No, fall on the 0.
08. So actually, it'll be on the 0.
Yeah. The 7 here.
Right. So I created this demo probably 3-4 days ago. So what I'm going to do is I'm now going to run the application that would actually put data into the database. Not that one. What is the command again? Crap. I need to call this. So I'm just gonna run the Java sample that we have on GitHub. On Eugene's presentation, he has a link to it, so you guys can download the source code. So now it's running as a Tomcat. Now, this is just a little controller that I made. And right now, if you create a new object, then the shard key is going to be between the from number and the to number. And what that from number to to number is exactly
3D.
Now in UTC. That's the from. And the 2 is now in UTC plus the to the power of 18, which is 3 days buffer that we're talking about. So now I can do create user. And I'm going to create user
MongoLA.
MongoLA. So now this will use the Java code Tomcat to create the user ID, which is basically the object ID that it's created, and then it
And
will
then the shard key
generate the shard key,
from.
right? And
So
then
essentially, you have a function that
Yeah.
generates the shard
It
key
will
from
show you the source code too.
object ID.
right. So now the username will be the username that I enter. So MongoLA in this example. So if I go back to the terminal and go here. Now we have MongoLA on top. So it still has actually the 137.2.
Yeah, so it will be in the chunk 1.
So it'll still be
Chunk 1.
137.
37.2 will go into chart.
It'll go to chunk 2.
Well, chunk 1, yeah, not the 1.
Actually, let me scroll up a little bit. 137, I'll just copy that. So that's the value versus,
So 2 here, so it'll be higher than.
yeah. So this one goes to chunk number 2. You can't really see it here, but if you really want to see and make sure that that's the behavior, then we can just connect to Mongo, localhost, and then this would be the first shard. So now I'm connecting directly to one of the MongoDBs, which is the shard 000. So in this one, we have Rick Chen, Eugene. We don't have the new one, which is Mongo LA. And then I'm connecting to shard number 1. So we have Mongo LA there. So I'm going to connect back to the Mongo S, which is the sharded environment. So now we have all the users again. Now, if we do not pre-split, then every single user that comes in is going to go to shard number 1. And then it'll just keep going that way until eventually it hits the maximum chunk size of 64 megs for that chunk. And then it'll realize that it's full. And then depending on the shard key, let's assume that the shard key that goes into that chunk is this one plus 10,000. Then it'll try to split it in the document so that it'll be equal in terms of size, 32 megs and 32 megs. So even though I'm inserting 100,000, it doesn't mean that it's going to be 5,000 and 5,000. It could be 4,000 because these 4,000 users are older and they're actually playing more. They have more data. So in our game, it will be they have more cars, they have more friends, so that their document is larger than the rest of the people. So it'll try to automatically split it up into the even size. And so when that happens, then you will have one chunk on 0 and you'll have 2 chunks on 0. And then you'll keep going that way and you'll get more chunks and more chunks and more chunks until this one has 10, this one has 1. So the difference is 9. And then the balancer will detect the difference and they'll, wait a minute, this one has way too much. And we're going to move that 9 and try to balance it. So what is the balance? Well, we're going to move 5 of those to here. So when they try to move that 5, they're going to try to move them one by one. So if it's not very active, it's fine. But our problem is with the game, people are playing and they're updating at a pretty consistent rate, and this is like really, really high throughput. So when that happens, the balancer, every time it tries to move a chunk, there's a write that goes into it, and it'll kind of hold off to the right. And if you do that, like with a really, really high load, then that becomes our problem. So our solution to that is basically we want to do a pre-split. So what pre-split means is instead of waiting for the data to go all the way to 64 and then they'll split it halfway, we're going to create a bunch of mini chunks. And we're creating the mini chunks on both of the, in this example, both of the shards. So we're going to say that, okay, from the shard key number 0 to 10,000 go here, from 10,001 to 20,000 they go here. And then we'll just alternate here, 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 right? So if we alternate the range, then if we know that the shard key is always going to be progressively larger, then when we create what we call the pre-split is we create a 0-size chunk. So we create somewhere in the future. So we say, okay, today's date is, or the shard range that we have is this. So for now, it's going to be 137, etc., etc. So what we're going to do is we're going to add that 3 days ahead, or whatever, how many days ahead you want to do a pre-split. And you tell Mongo to say, okay, now you're going to pre-split. You're going to, basically this is your data, and this is the data that goes from shard key number X all the way to Y, and you say that I want to cut it right here. And when you cut it right here, you basically keep this data intact, and you have 0 data on this side because you just cut it much ahead of time. So when you cut it that way and you just keep cutting in this side, you have 0. You have no data. There's no user activity going into there. It's just empty chunks. And then once you have empty chunks, then you start moving these chunks equally to X number of shards. If you have like 20 shards, then you move them equally to 20 different shards. And therefore, when you do a pre-split, you can do it when your application is running. When it's running, it doesn't have any overhead. It's very unnoticeable. So once you do that, eventually the shard key, because it's based on time, it will eventually catch up on that range. And once start filling the data, then because our strategy is based on MD5 and it's random enough, usually that one chunk that goes there, if you have a lot of users, it becomes, say, 10 chunks on one shard, but then it also becomes 10 chunks on different shards as well. So now you have, let's say in this example, you have 2 that will have 10 shards by the time it fills up the data. So usually we don't need to rebalance the data anymore. Obviously, we want to do a rebalancing just in case if for whatever abnormality, you either have more users signing up to that one period, maybe you have a special advertising that will just push a lot of users to there, or maybe in some anomaly you also have more quality users, so they actually play the game more and have bigger data, then it might be unequal and you still have to rebalance and move the chunks around. But what you can do is in Mongo you can do what you call the active window for rebalancing. So you can say that I want to balance from 2 a.m. all the way to 4 a.m. and that's it. So during that time when there's not as busy, depending on your traffic, then it'll start moving chunks around, and by the time 4 o'clock comes in, everything is rebalanced again, and then people come in and they'll be performing the way you want it. So the last one that I want to show to you guys is basically just the Java code.
So you guys constantly adding shards as more users come, adding?
We do a pre-split based on, in this example, you have 3 days, right? So when you have 3 days, and let's assume that you have 3 shards. I know that I'm going with 3, with 2 here, but for our example, let's assume that I have 3 shards. So when I pre-split, I say that from day 1, on first day, everything goes here. Oh, I'm sorry. Let me backtrack a little bit. So when I have 3 days, my timestamp or my shard key is going to be between today and 3 days from now. So my shard key is going to be the epic timestamp in seconds between that to that,
here.
and that's 3 days, right? So if that shard key is within the first day, it'll go to the first shard. If it's within the second day, it's going to go to the second shard. If it's within the third day, it's going to go to the third shard, right? And then as time rolls in, let's say you do half a day has passed. Now, so the now is going to be the 12th p.m. here. So this will get basically half a day worth of data, right? If it falls on the first day. This one still get the 1 full day of data, second day. This one is going to get a full day of data, third day. But then you have now the 3.5, right? Because one half day has passed. So you have a 3.5 right here. And if you pre-split far enough, so let's say I pre-split for 30 days, and the pre-split order is going to be 1, 2, 3, 1, 2, 3, 1, 2, 3, and it'll keep going that way. So now you have half of one here, half of one there. So you're still distributing it equally.
And it just rolls around.
It just rolls around and around and around. And then the reason why we do not want to pre-split much ahead is just predictability of the application. So we may need 3 shards right now, but if the game got really popular, then we might need 4 shards. And then instead of 1, 2, 3, 1, 2, 3, 1, 2, 3, we got to do 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4.
So the Mongo service is taken up, or you write the program?
We write the program. It's actually not a program. We just write a script in JavaScript, but in Mongo,
you can do a pre-split. I can show you the commands. Where is my terminal? So this is a pre-split. It's pretty straightforward. You use admin. Let me just put that up a little bit.
Here, why don't you use this? It's a green button.
So you use the admin, and you run db run command, and you want to split this database or collection. So database.collection sample.user, and then you tell them where you want to split it. So this is where you want to split the data, and then after you split it, all it does is just split the data, but it still stay in the same shard. But if you want to distribute it equally to the rest of the shards, then you have to manually move them. So you move the chunk of that, and then you find the same shard key, and then you put it to the destination, which is in this example is shard 0001. So my script is basically just calculating the 3 days divided by the number of shards that we have, and then I'm entering the last chunk, which is the one that has the max key value, and then I'm starting incrementing based on that. So if the last time I pre-split it, if it goes to shard number 7 and there are like 20 shards in there, then I'm gonna do a shard key with that middle, the new middle, and then I'm gonna move it to. Did I say 7?
7.
I'm gonna move it to 8, and then after I move it to 8, then I'm gonna split it again with the future date, and I'm gonna move it to 9. Split again, move it to 10. Split again all the way to 20, and then split again, move it back to 1, and keep going.
Is the shard key on that generated by the program?
Yes.
Yeah, we'll show you the source code for the program, and as well as I'm going to share that code with you guys. So if you wanted to use it, you can.
I'm gonna open the project. There.
So I got a question for you. So even though you're kind of pushing these off in the future, you're distributing data to all the shards all the time, right?
Yes and no. I mean, because the new users are coming in, and I gotta show you the code. It basically introduced a predictable randomness, so that if you have like, for whatever reason, if you have like 1 million users coming to the system almost at the same time, it will be distributed equally.
Yeah.
Or close to equal. It's not perfect equal.
If you want fully randomness, then the hashing algorithm that is provided inside Mongo 2.4 would probably be good enough for you.
Got it. Yeah, I didn't really understand what the problem with using the hashing was.
Sorry. I might have some sensitive source code I'm going to
It seemed
replug.
like what you were saying was when using the hashing algorithm, you get inactive users mixed in with active users in the same chunk.
In the same chunk, right.
That's the problem.
So then when you're pulling that chunk, because it's pulling the entire chunk into memory, you're getting all of those users. But what we want is to be a little bit more predictable in terms of we know that most of the users that are playing at a given time are in a specific date range.
So that's kind of why you use kind of the time as a lot of your shard key, because it's always kind of taking you to that.
Right, we have
active
we have a time piece that's part of the shard key. Correct.
Got it.
User.
You need Wi-Fi?
No, I just need to. I close it because I have our source code, our game source code up.
You're supposed to clean that out before.
Do not steal my laptop. Let me see here. Cie Games. Seminar.
Yeah, and the PowerPoint slides, I
All
kind
right.
of go into the basics of doing exactly the same things you did in terms of recreating the two shards. Obviously, you're not going to do this in a production environment, like you said, because you'll want to create replica sets, and you'll want the MongoDBs on separate machines. But for a local host environment that if you're testing your sharding scripts or developing locally, the example is good enough.
Okay. So
one of the ways to generate the shard key,
I'm trying to make it
make
bigger.
it bigger.
Yeah. How do I do font? Oh, you know what? Let's do this.
So it's possible that two objects might have the same shard key.
Well, no, because it's
The MD5.
yes,
Got it.
the MD5. Well, I mean, I guess there could possibly be the same shard key, but very unlikely. And in the event that there are, it's not a big deal for you because it's going to go to, it's just going to a shard, right?
Right.
There you go. There you go. Now I have to scroll. Let me.
Right. So it,
Okay. So essentially, this is just for error handling. If there's no user ID, it'll return 0, but it'll never be null. So just focus on this side. So the first thing it does is it grabs from the MD5 value of the string of the shard key. So the 0FF, etc., that 32 characters of MD5. Well, not MD5. There's the 32 characters of hex. We're just doing an MD5 on it because if you notice, the regular the object ID that's generated is kind of like a little bit in the series. So if we do not do an MD5 on it, then it's not random enough. So it'll be heavy on one shard compared to the other. So we want to do an MD5 on it. So MD5 is kind of like somewhat random, but it's random enough for us. So we take that, and then we grab the first 20-bit, which is essentially the first 5 characters. And then we convert it to a number, right? So this is just basically telling that this is a hex number, a string hex number, and we want to do a 16 by doing a parse to it. So now we have 20 bits, but all we need is just 18-bit. So that's how we do the bit. So we get the first 20-bit, and we do an AND operation, bit operation, and then you put the 18-bit value in there. So you get the 18-bit, and then as we know it, the object ID has a time in seconds. So we just take the time plus the the number randomization of that the first 18-bit, and the 18-bit translates to number of seconds of 3 days. Yeah. Are there any questions?
I have one.
Sure.
Using MD5 as your basic hashing algorithm.
Yeah.
Why that one instead of the SHA-1 hashing algorithm?
Because this is not about security. This is about randomness. So MD5 is very lightweight compared to SHA-1, and we don't. If you somehow figure out your shard key, then
It doesn't
we don't
do
care.
anything.
Yeah.
Okay.
Just got a game.
Right. Any other questions? All right.
You want to go into the second, or go into detail of how we use that?
How we use this?
The object ID, shard key, to do a find and so on.
Oh, sure, yeah. So one of the example, I believe, is controller short range. There you go. So we have /user. And then this is the way I pull the data from the database. For example, I want to pull a user ID, certain user ID. So it'll be, say, this guy. So this will call the database, and basically, based on that, all we know is we're trying to load that user with that object ID. So in our code, what happens is it'll take the user ID and recalculate the shard key again. And then when it try to do the Mongo connection, it'll tell the Mongo and say, I want to get from the database with the user ID of that and shard key of that. And then because shard key is a part of the query, then it'll target that particular shard and only query that shard as opposed to all the shards in there. That's basically the only way sharding will make sense if you always include the shard key in your query. If you don't include it in the query, when you develop it, it'll look as if it's working. But what actually happens is it'll send that query to all the shards that you have, and then only one of them is going to return the result. And that's going to be really inefficient. And instead of getting performance out of your sharding, if you don't include the shard key, then you're actually getting penalized for it. So be really careful with that.
Show the repository code.
Repo code.
Or did
So
repository.
so for that controller, it'll be that one, user / and then you pass the user ID. And I have a user DAO.find. And if I look at the implementation of that, it's essentially
This is the DAO.
this is DAO. There is a find by string ID. So find by string ID is just basically creating the object ID from that string ID, and it goes to find. And find calls the user repository.get user ID. So we actually modify. We're using Morphia for this. So Morphia is essentially used to be a open source project that this guy Scott Hernandez started, and is creating an abstraction layer for Java. So it's a lot easier for you to use it as opposed to use the native driver. And one of the great feature on Morphia, it does the serialization and deserialization from Mongo to your own object, so you don't have to do that work. I believe Scott has been hired by Tengen, so he's part of Tengen, and I heard rumors that Morphia is going to be the part of the Java driver sometimes in the future. So yeah, he's very involved, a very smart guy, and I hope he hears us. But the Morphia that we've been using has been stopped for development. I'm guessing it's because they want to do the Java driver. So I'm dying for an update. But while waiting for update, we actually modified a little bit because it does not support sharding. So
Data store?
Is it data store? Okay. So we created this that implements the data store that Morphia created.
And it extends their data store.
So it extends that data store, and we have a shard key annotation that basically does it on the fly. So if you have the user, you have the user object, which is going to be the object that's going to go into the user collection. If you annotate the shard key, then it'll automatically, even though you're just looking for an ID, our modification will insert the shard key as part of the query, so that we ensure that we always include the shard key.
In this example, the data store shard implementation, I didn't have enough time to give you the full implementation, so I have a to-do in there. Basically, this only gives you a sample of how to do it for updates, and we gave you an alternative solution how to do find using just the regular method instead of using annotations. But anyone is welcome to, go all out and implement all of the interfaces that interface methods that need to be added for the get, and you can recontribute or contribute to actually Morphia. That probably would work best.
Yeah. Any questions? All right, I'm gonna conclude the demo and have Eugene finish the presentation.
All right. All right, so if you want to access the demo, you're welcome to take a snapshot of this, and I'll give you the GitHub. I also have resources that we used for this. The demo is on here as well. It's my GitHub account, and there's some really good, more detailed PowerPoint presentations by Tangent that I recommend.
QR code again?
The slides are also going to be up on the meetup page, so.
Yeah, so if the slides are on the meetup page, you can click on the links here, and thank you guys.
Thank you.